Hi, everyone, and welcome to my session, Climbing the Query Peak. My name is Lior King, and I'm a senior instructor and solutions engineer at Couchbase. This session is an introduction to the NQL language, N1QL, the language of Couchbase NoSQL database. So what are we going to talk about? We'll discuss the basics of NQL. We'll see how you can utilize the query workbench, which is the user interface for writing and testing NQL commands. We'll also learn how to create and use indexes. And NQL is not just for querying data. You can use it also to change data as well. So we'll learn how to do that too. We'll learn how to handle objects and arrays, how to perform joins, and at the end, how to embed NQL commands in your code. Before we get started, here is what I assume you already have. You should have some prior experience with relational databases such as Oracle, MySQL, Postgres, etc. You should be familiar with the standard SQL language as well, and you should be familiar with the JSON format. And that's all. That's all you need to know. So let's get started. What is NQL or N1QL? N1QL, which we like to pronounce as NQL, is an expressive, familiar, and feature-rich language for querying, transforming, and manipulating JSON data. NQL stands for Non-First Normal Form Query Language, and it is based on ANSI SQL. That's right. So if you know SQL already, then you probably know most of NQL as well. Its query engine is optimized for modern, highly parallel multi-core execution, and it is supported by a very powerful indexing engine too. NQL extends SQL to handle data that is nested, that is containing objects and arrays, and also data that is heterogeneous, that is schemaless and non-uniform. A NQL statement looks pretty much like a SQL statement, and it contains all the familiar clauses of SQL that you probably are familiar with. The select clause, for example, is used to specify the fields to project. Select star works exactly like in SQL as well. The from clause specifies the bucket from which you query. This is a bit different than SQL, because in SQL you mentioned table names, and here we don't have tables, right? So you specify the bucket from which you wish to retrieve the data. A bucket in Couchbase is like a database in a relational database. The where clause is used to filter only the desired documents from the bucket you're selecting from. The group by clause is used for aggregating data and is also used, it's used together with functions such as count, sum, average, etc. The having clause is used for filtering data after the aggregation. The order by clause enables you to sort the results, right? Exactly like in SQL, and you can sort by an ascending order or descending order. The limit clause sets the maximum number of results that you can fetch. And the offset clause is used for starting from any location within the result set. So this is extremely familiar, I guess, for you if you are familiar with SQL, right? You can also use the distinct clause exactly like in SQL. And if your bucket name or any of your fields has a special character such as a hyphen, a blank space, or an ampersand, then you need to enclose that field name or bucket name with backticks, just like here in this slide. So unlike SQL, NQL is case sensitive. When it comes to field names and bucket names, it's very important. So for example, field 1 with a capital F is not field one with a small f. These are two different field names, attribute names. And this case sensitivity comes from JSON, right? JSON is case sensitive, therefore NQL is case sensitive as well. NQL has special extensions to support the JSON documents inside Couchbase. Let's look at a few. To get the document's metadata, use the meta function, just like that. If you are interested in the document key only of the metadata, use the meta, open parentheses, close parentheses, dot ID, just like that. That's how you address the document ID only. To query a document using specified document keys, use the use keys clause, like you can see here. If a field has a value, it is not null, right? It has a value. But if a field has the value null without double quotes, it is considered null. If a field does not exist in a document, it is considered missing. You can issue a NQL query that queries documents where a specified field is missing or a specified field is null or is not null. So you can use these clauses to select whatever you need. NQL offers dozens of functions that you can use in your NQL statements. First of all, there are the familiar aggregation functions like sum, count, average, maximum, minimum, and others. These are all exactly like SQL. We also have date and time functions like now_str, which gives you the current date and time. Date_add_str that helps you perform date and time calculations. Date_diff_str helps you find the difference between two time variables. Number functions are also used for mathematical calculations, such as ABS for absolute function, power for calculating x in the power of y. Random is a function that generates a random number, and there are many other functions as well. String functions help you to handle and manipulate strings, such as upper and lower for uppercase and lowercase strings. Substr for substring extraction, and many others. Array functions can perform all sorts of operations on arrays. For example, array_concat concatenates arrays to form one unified array. Array_count counts the number of elements in an array. Array_append appends an element to a given array, and so on and so forth. Object functions operate on objects, a set of values in curly brackets in your JSON documents. For example, object_add can add new attributes or fields to a given object, and it returns the updated object. Object_concat concatenates objects together and return a unified object. Object names returns an array containing the attribute name of all the different fields, all the different attributes inside your object. Type functions, for example, enable you to get the type of a given attribute or field. The function called type gets a field and returns the string number if it is a number. It returns string if it is a string. It returns null if it is null. The function isArray, isBoolean, isNumber are all kind of Boolean functions that return true or false depending on the field's type, and there are all kinds of them. Conditional functions are also very, very useful in your NQL statements. The case clause is the same as you're probably familiar with from N1QL, and it works exactly the same. It evaluates conditional logic, and it performs an action, or it returns any kind of a value. Decode is a simple conditional function that can be found in Oracle as well. NVL returns an expression if a given value is null or and so on and so forth. And so there are, dozens of functions in NQL, and this is just a small sample of them. For a complete list of all the functions, check out Couchbase documentation, which also contains examples and further details. Couchbase comes with a web-based user interface out of the box. In that user interface, there's something called Query Workbench, which is a UI tool for writing and executing NQL statements. With the Query Workbench, you can also examine the results of a NQL statement and get performance metrics and information that can help you to improve the performance of your statement and get more information. Let's talk about the Query Workbench and drill down into it just a bit. By selecting Query from the menu on the left, you get into the Query Workbench. The screen is divided to two panes. The upper pane is the query editor, and beneath it is the query results. After you type your NQL statement in the pane above, in the query editor, you can execute your statement by clicking the execute button. The results are shown below. You can see that the result is a kind of an array of JSON documents. And that's your result set. It's usually an array, and it contains the documents that have been selected. And you can, of course, scroll and see all the documents that have been selected. Notice that the Query Workbench shows you all kinds of statistics about your query execution. You can see the total elapsed time. You can see the total execution time, the number of documents that have been selected, and the total size of the result set, which is in this case 953 bytes for the entire JSON result set. You can also see the results in a tabular format by clicking on the table button. The results are presented as a table. The table can also have mini tables inside. That's in case you've got nested elements. To examine the execution plan of your query, you can click on the plan button. The execution plan is presented in the lower the lower window here, and you can notice that the magnifying glass icons here can help you zoom in and out to have a better view of the execution plan components. On the right side of the screen, notice the Data Insights pane. Here we can see different document patterns that Couchbase have found. Next to each pattern, there is a small arrow that you can press on. If we press right here, you can see all the fields of the documents that have this type that we've selected. So what Couchbase is doing is it samples about 1,000 documents from your bucket, and it estimates your schema from that sample of 1,000 documents. And this is what you see. You see the different patterns that Couchbase have found in your bucket, and you can use that information to build your query. Let's try to run a simple query using the Query Workbench. This query selects one document from travel sample bucket. When we execute this query, we get the following error: no index available on key space travel sample that matches your query. What does this error mean? Couchbase query engine has to have an index that covers the document of the query. Has to have it. An index that covers all the document keys in the bucket is called a primary index. This is the syntax for creating a primary index. And here is an example of a primary index creation for the bucket travel sample. The primary index can be used for ad hoc queries when you don't necessarily have indexes that support your query. Primary indexes are optional, and you should try to avoid them as much as possible, especially in production environments. The reason is they usually produce subpar performance because Couchbase would probably need to scan all the documents in the bucket to perform your query. Let's create a primary index for the travel sample bucket using the query workbench. As you can notice, the index has been created successfully. Now, let's try to execute our query again to get one document from the travel sample bucket. If you click on the plan button, you will get the execution plan that Couchbase created for your query. Notice that there is a primary scan here in the execution plan. That means that Couchbase have used the primary index to scan document keys in order to execute your query. Now let's execute another query. And this query counts the number of routes that we have in the travel sample bucket. Notice how much time it took for executing this query. Why does it take so long to count the routes? Let's take a look at the execution plan by clicking the plan button. Notice that Couchbase used the primary index to scan the document keys, and then Couchbase had to fetch every document and filter documents that are of type route. Notice the number of documents that had been fetched to perform this query. That takes quite a long time. So how can we make this query run faster? Just like in relational databases, you can create indexes on selected fields in your documents. These indexes are called secondary indexes to distinguish them from the primary index. The syntax for creating secondary indexes looks pretty much like the same in relational databases. And here is an example of creating an index on the field type of the document of the documents in the travel sample bucket. You can also create composite indexes, which are indexes that are composed of more than one field. Just like in this example where the type field and the airline field are both specified. Let's create an index on the type field. Now that the index has been created, let's run the same query again. Now the query runs much faster, right? That is quite faster than before. Let's take a look at the execution plan. Notice that now Couchbase scans the new index that we've just created, instead of reading all the documents inside the bucket like it was doing with the primary index. Partial indexes, also known as filtered indexes, are indexes that cover a subset of the documents in the bucket. Since a partial index doesn't cover all the documents in the bucket, it consumes less disk space and less memory resources than an index that covers all the documents in the bucket. Here is an example of a partial index. Notice the where clause, which is a logical expression that filters which documents will be covered by the index. It is a best practice to use partial indexes instead of indexes that cover all the documents in the bucket. Another type of index is called a covering index. Covering indexes cover all the fields that are needed to execute a query. A covering index delivers the best performance since Couchbase will not need to read any data from the documents. It has all the data that it needs in the index itself. So let's see an example. Here's a query that fetches the airline, the number of stops of all the routes in the travel sample bucket. In order to create an index that will cover all the fields for this query, the index needs to cover the airline field, the stops field, and the type field. So let's create a covering index for this query. Notice it covers all the required fields. To improve the index even further, we can create a partial covering index. This index is more optimal than the simple covering index because it produces a smaller index that covers only the routes documents, while it still covers all the fields required for the query. To understand how a covering index can boost the performance of your queries, we first need to understand how Couchbase executes a query without a covering index. So the client submits a query to the query service. The query service reads, analyzes, parses, and optimizes the query and creates an execution plan. Then it executes the execution plan, which tells it which index to use. The query service calls the index service and gets the values of the indexed fields and the document keys that they are referring to. So the query service then calls the data service to get the fields that are not covered by the index. The data service sends the documents to the query service, and the query service performs then aggregations, sorting, and other operations and prepares the final result set. The final result set is then submitted to the client. Now, let's see what happens if the index covers all the fields of your query. The client submits a query to the query service. The query service creates an execution plan. Then it executes the plan and calls the index service. It gets the values of the indexed fields and the document keys they refer to. And since the query service got all the information it needs from the index service, it doesn't call the data service. It just performs the final aggregations and sorting and other operations and prepares the result set and submits it to the client. It's obvious why covering indexes deliver better performance. They don't need to do extra calls to the data service. Let's see how indexes can impact the performance of your NQL statements. The following query retrieves the source airport, the destination airport, and the distance of all routes that are longer than 13,000 kilometers, which are about 8,000 miles. Let's execute this query. Notice how long it took to execute this query. Let's look at the execution plan. Notice that this query scans the index IDX_type, which we've created earlier. And notice that Couchbase needs to fetch the documents to get the fields source airport, destination airport, distance, and type. And then it filters the documents that have a field name distance with a value greater than 13,000. So now let's create a covering index that covers all the fields that, that our query needs. Now let's run our query again. Amazing. Look at how fast the query runs now. Using indexes has lots of benefits, but it comes with a price. On the one hand, indexes expedite your query's performance, but on the other hand, indexes consume memory and disk resources. If you have a lot of data mutations per second, the indexes need to be updated constantly, and so they might consume a lot of CPU resources as well. So don't just create indexes for nothing. Create them when they are actually needed, and of course to meet the SLA requirements of your application. The Enterprise Edition of Couchbase has a tool called the Index Advisor. The Index Advisor can analyze a NQL query or a NQL statement, and it can generate an index creation recommendation for it. Let's drop the index we've just created by issuing a drop index statement. Now let's issue the same query again, but now instead of executing it, we press the advice button. Couchbase presents recommendations for creating covering indexes and non-covering indexes for you. Indexes that can boost the query's performance in the form of create index statements, as you can see here. By clicking the create and build covering index button, you can actually execute these create index statements for building a covering index. So you don't need to copy that statement. You just press on the button and it is created for you. You can also click on the create and build indexes button and that will create non-covering indexes for you. Let's press on the create and build covering index button. Once the index is created, let's run the query again. Now it certainly runs faster. That brings us to the next topic, which is DML statements. DML statements, or data manipulation language statements, are statements that change your data. Just like SQL, NQL offers an insert statement for adding documents. But the insert command in NQL is a little bit different. This is because we are not inserting a row that contains different fields, but rather inserting a document that contains all these fields inside. That is why the insert command requires only two parameters, one for the document key and the other is for the document itself. Since all the fields are inside the document, the values clause doesn't need any further parameters. The into clause specifies into which bucket you wish to insert the document. Note that if there is already a document with the same key in this bucket, the command will fail and produce a duplicate key error. The upsert command is a unique command to NQL, and it is not found in SQL. Upsert looks very much like the insert command. It will try to insert the document into the bucket. But unlike the insert command, if a document with the same key already exists in the bucket, the upsert command will overwrite that document. Unlike the insert command, which will produce an error in this case, the upsert command will replace the entire existing document with a document specified here in the command. The update command in NQL looks exactly like the update command in SQL, and it works pretty much the same. You specify which bucket you wish to update. The set clause specifies the fields you wish to update and the values to update. And each pair is separated by the comma. And the where clause specifies a logical expression that selects documents to update. Here, we'd like to update all the documents of type airline. And in the airline field, they need to have the value ABC. The delete command in NQL looks exactly like the delete command of SQL, and it works pretty much the same as well. You specify which bucket you wish to delete from, and use the where clause to specify a logical expression that selects the documents to delete. Here, we'd like to delete all the documents of type route that were updated since January 1st, 2020. Since Couchbase is a document-based database, your documents can have nested objects and arrays. Let's discover how NQL handles nested elements in your documents. NQL has a special syntax for handling JSON structures. Let's take a look at the random airport document in the travel sample bucket. Notice the geo field. It is an object that holds child fields. To reference a child field in NQL, use a parent field name dot the child field. So to access the altitude field, you need to specify geo.alt. To access the latitude field, specify geo.lat. To access the longitude field, specify geo.lon. Arrays in a JSON document are recognized by square brackets. Here is an example from the beer sample bucket. The address field is actually an array containing two strings, 26 Osier Road and Wandsworth. To access an array element, use the field name of the array and the index of the array element in square brackets. The first element gets the index 0, the second element gets the index 1, etc., etc. To search for a value within an array, you can use the in operator or not in, like in this example where we search for the string Wandsworth in the address array. Arrays can also contain objects and not just plain values. NoSQL offers a special syntax for querying elements of objects inside arrays. This is the general syntax for searching for elements in an array of objects. Let's look at an example. Here we are using the word any to search for an item in the array schedule. NoSQL needs to iterate over all the items of the array. So the X here is actually a loop variable that you can name for iterating over the array's items. Think of it as a loop where X is the loop variable and it represents the current item of the array. Every iteration is a different element. So it goes from the first item in the location 0 to the last item of the array. So in this example, we are looking for the documents that have an array named schedule. And in that array, there is a field day with a value less than 2. The clause any indicates that we are looking for at least one item in the array whose day value is less than 2. If such an item exists, then the document is selected. Here's the same query, but now we're using the clause every instead of any. That indicates that we'd like all the elements of the array to have a value in the day field that is less than 2. If there is one single item in the array that has a value in the day field which is equals or greater than 2, then the document will not be selected. NoSQL enables you to create an index that covers items in arrays of objects. Here is an example for doing that. So we create an index on the day field, which is in the objects of the array schedule. Notice that we use the same trick of having an iteration variable, which is in this case called v. So v.day is the field day in the current item we iterate over and is represented by the variable v. Notice the special clause distinct array. In most cases, you would want to keep distinct values for the day field. Using the distinct clause will ensure that Couchbase will not duplicate values for the field day. With SQL, you can use inner joins, left outer joins, right outer joins. Well, in NoSQL, you can do the same. You can join different document sets using NoSQL. Let's learn how to do that. Joins are necessary when you need to reference data rather than embed it in the same document. In that case, you'll need to look up and join the reference data. So if you happen to have a field of data in one type of document on the left, which relates to data in the field of another type of document on your right, then you can join across this relationship, and it's very simple. Again, very much like in SQL. You start with selecting the documents on the left side. So let's give it an alias route. Then you join it with the right side. Notice that since both sides are from the same bucket, we use the same bucket in the join, but give it a different alias, the alias airports. Then we specify the join condition, just like in SQL. We join the destination airport in the route documents with the FAA field in the airports documents. Then we need to specify that the document set on the left side refers to documents of the type route. And the document set on the right side refers to documents of type airport. Then we can add some more filtering conditions as much as you wish. As you've noticed, this looks very much familiar because ANSI SQL works pretty much the same. That's the reason this kind of join is called ANSI join. Bear in mind that ANSI joins require that an index will be created on the field you are joining with on the right side, just like the create index command showed here. Another option at your disposal is to join documents by using a document key. Suppose you have a field in one type of document on the left, which relates to the document key of another type of document on your right. Then you can join across this relationship. You start with selecting the documents on the left side. Let's give it an alias routes. Then you join it with the right side. Again, both sides are from the same bucket. Since we use the same bucket for the join, we need to give the sides different aliases. So the right side will have the alias airlines. Then we specify a special nickel clause on keys. On keys. This clause refers to the document key on the right side, but with a field from the left side. Then we need to specify that the document set on the left side refers to documents of type routes, and the document set on the right side refer to documents of the type airlines. Then we can add some more filtering conditions as you wish, as you need. Nickel also supports common table expressions, or CTE. Just like in ANSI SQL, ANSI SQL has the same feature. Common table expressions are used for simplifying nickel statements and are also used like a temporary document set that is created and dropped immediately after the use. Couchbase performs the common table expression first, and then it uses its results when it executes the query that uses the common table expression. Common table expressions can be also nested. So you can have one CTE, which can call or use a CTE that was previously declared. And this is exactly like the ANSI SQL standard. So you've written your nickel statement and you tested it with the query workbench, and now it is time to use it inside your code. Couchbase offers 4 ways to execute nickel statements. We've already seen the query workbench. In addition, you can use the CBQ command line utility. And you see where it's located in Linux boxes. Or you can also execute nickel commands using REST calls. This is an example of executing a nickel statement using a curl command. And of course, you can execute nickel statements with one of the SDKs maintained by Couchbase or other SDKs that are developed and maintained by the community. Couchbase has official SDKs in 9 different languages. All the SDKs offer 2 APIs to your data, the key value API and the NoSQL API. The key value API is the fastest and the most performant, but it requires you to know the primary key of the documents in advance, the documents that you wish to work with. For any other case, you would probably use the NoSQL API for running NoSQL statements, and for which you need to have, the indexes set up as you already know by now. Let's learn how to execute a NoSQL command within a Java application. This is a code sample of a simple query execution using Java, but in other languages, it's pretty much the same idea. Let's examine it. The cluster object has a method named query that can execute any query on any bucket or set of buckets in the cluster you are connected to. The query method executes the NoSQL command inside its argument. The method returns an object of type query result that holds the document set returned by the query. In this example, it is returned to the variable result. To process the result set, you can simply loop through the results of the query. And you can convert every result to a JSON object or to any object in your code. In order to prevent SQL injections and to reuse the same execution plan for recurring NoSQL statements, it is best to use parameters for your NoSQL statements. Let's see how it is done. To use parameters, you need to put placeholders within your code with a dollar prefix. In this example, we use a placeholder called $name. The query method accepts the second parameter of the class query options. Among these options is binding parameters to your query. You need to supply a JSON object that holds the parameters that match the placeholder's names. The placeholder $name will be replaced by the value that you specify, which is in this case is British Airways. You can also use parameters within the query workbench. You first need to place the placeholders in your query, and they need to be prefixed by a $sign. And then in this example, we use the $name placeholder. And now it can be replaced by a value that you can dynamically bind to your query. You can use the query workbench to test your queries even when they have parameters inside. After you've written the query, click on the cog icon on the upper right corner. A new window will be opened for you. In the named parameters section, specify the parameter name with a $sign prefix, and you can specify a value that you wish to test your query with. Then press on the Save Preferences button and execute your query. With that, we've reached the end of this session. So what have we learned? We've learned that NoSQL extends SQL by supporting document keys, arrays, nested objects, and other features of JSON documents. We've got a glimpse at the query workbench, which you can utilize to build and to test your NoSQL statements. The query engine uses indexes to execute NoSQL statements. Indexes will boost the performance of your statements. So we've learned how to create them, and we've learned about partial indexes and covering indexes. NoSQL supports ANSI joins, as well as joins by document keys. You can also use common table expressions to simplify your statements. NoSQL statements can be easily embedded in your code with Couchbase SDKs. There is a lot more. There are topics we didn't cover in this session, and you might want to explore them. We have an instructor-led course that covers all you need to know about NoSQL, the CD210 course. as well as the CD212 course that expands it even further. For more information, go to learn.couchbase.com. And that's it. My name is Lior King, and I hope you've enjoyed this session. If you have any questions, please submit them in the chat window, and I'll be happy to answer them. So thank you very much.